Hey guys, so we are going to continue our conversation about probability. So the last time, for your last lesson, we talked about theoretical probability and we also talked about empirical probability. Those two things are in your notes. However, I do want you to quickly take note of experimental probability because experimental probability is also called empirical probability or vice versa. So in the notes that you took during the first lesson, I want you to just go ahead and put maybe in parentheses experimental by empirical so that you know that a lot of times people refer to it as experimental. So today that's exactly what we will be referring to empirical probability as. Okay? All right. So just to review a little bit, when we are calculating the theoretical probability, there's a formula that we use. And if you can remember, it is the number of favorable outcomes that goes on top, and then the total number of outcomes goes on the bottom. Now, in this type of probability, this is basically deciding what should happen if all outcomes are equally likely. So when we talk about favorable outcomes, for example, I think we used tickets, last time. So if I bought 3 tickets for a raffle and I know that they sold 60 tickets, then for me, it would be favorable for me if they were to pull one of my 3 tickets that I purchased because that means I'm going to win. So that makes that a favorable outcome for me, right? So when we're talking about the probability of something and we're looking for the favorable outcome, we're talking about the event that we're looking for. So if we're looking to see how many yellow crayons I'm going to pull out of a box of a mixture of a variety of colors, and we would need to know how many yellow crowns are in there, and we would need to know how many crowns are in there total. The yellow crowns again would be the favorable outcome because that's what we're looking to pull. We're hoping that we pull it. And then the total number of outcomes is the amount of crowns. But it's really important to note that theoretical probability is what should happen if all equally likely outcomes are there. So let's move on to experimental probability. So when we're talking about experimental probability, we're talking about the outcome based on repeated trials of an experiment. And it can be calculated through a formula as well. But this formula is based upon an experiment that you have done. So there's an example that says, consider the following. A coin is flipped. What is the probability of it landing on heads? So if we took a coin and we flipped the coin, let's say we flipped it 20 times, and we wrote down how many times it landed on heads. We're doing an experiment. We're doing an experiment to figure out the probability. However, with the experimental probability, the answer that we're getting from the formula is literally what actually happened when we did that experiment. So experimental, think of an experiment because ultimately that is what you are doing in order to figure out the probability. So experimental would be what actually happened. Theoretical would be what should happen. Okay? So that's important to note and understand the difference. So when we are talking about the formula for experimental probability, the top is going to be the number of successes. So we were looking to flip a coin and we wanted it to land on heads, every time it lands on heads, that is a success because that's what we're looking for, right? Okay. On the bottom would be the total number of trials. And remember, trial is each time I flip the coin, right? So in this situation, we had 20 trials because we flipped the coin 20 times. So I hope that you guys are understanding the difference between the theoretical and experimental / empirical. So once again, theoretical is what should happen. Experimental is what actually did happen. Okay. So on the bottom, it becomes times when we kind of begin to compare to see if we're going to get the same outcome or to see if our theoretical, what should happen, comes close to the experimental probability, what we actually do. So when we were talking about the coins, we have a theoretical probability, the number of favorable outcomes over the total number of outcomes. If we're just talking theoretical, we have a coin. The coin has two sides. It can either land on heads or it can land on tails. So the number of favorable outcomes, when we were talking about seeing how many times it lands on heads, it would be one because on a coin, there's only one side that has a head on it, right? The other one is tails. However, the total number of outcomes is two because it can land on heads or it can land on tails. So if you were to plug that in, how they did it right here, yeah, that just didn't go right. How they did over here, then our probability would be 1/2. And also, we also said that can be 50-50. It depends on how you would like to write it. So a lot of people say, oh, you have a 50-50 chance, or you have a 50% chance of getting heads. Okay. All right. So now that we figured out what the theoretical probability is when we're flipping a coin, let's kind of do an experiment to see and test out our theoretical probability. So we're going to go to the next slide and we're going to test it out. So due to the fact that we are not in person, I'm going to have to figure out a way. I brought up a, see if I can split it so we can see both screens maybe. So what I did was I brought up a coin, and what we're going to do is we're going to flip it digitally so you can see. When we flip it digitally, we're going to record what we get, and then we're going to compare it, okay? So if we were thinking about, before we flip this, if we're thinking about the coin and we're thinking about the results that we got theoretically, through our theoretical probability, that means that technically we should get 5 heads and we should get 5 tails if we were looking at the theoretical probability. However, we need to do an experiment in order to find the experimental probability. So let's go ahead and do it. So we're going to tally up on this side. All right. Okay, we have tails. So we're going to put 1 for tail. Now let's try to flip it again. Okay, tails again. Okay, we got heads this time. Okay, what just happened to you guys? Technical difficulties is real today. Okay. All right, let's go back and let's flip again. Another tails. Another tails. Okay, we got heads. Tails. Heads. Tails. And the last one is going to be tails. All right, so let's get off of that page and go back here. Okay, so now let's count up and see what we have. So our favorable outcome was landing on heads. How many did we have? We have 1, 2, 3. So our top number will be 3. And the total number of outcomes, we flipped it 10 times, so it was 10. So you tell me, did the experimental probability match the theoretical probability? So reminder, the theoretical probability was 1/2, 50%. So 3 out of 10 trials is not exactly 50%. So we do want you to note that, like, when we're doing experiments, everything is not going to turn out the exact way that we predict. So theoretically, yes, ideally, it would be 1/2. However, when you're doing more trials, the closer you'll get to the theoretical probability. So since we only did 10 trials, our number is a little bit off. So if you had 1,000 trials, then you probably would be more at 50%. So it just depends on how many trials you do, but technically it'll always be around that amount, about 50%. But again, it's very rare. I'm not saying it can never happen, but it's very rare that it's going to be exact. So it didn't match it. However, it was too off. So I mean, technically, not too bad, but it didn't match. So we're gonna put no. Okay. So what I do want to do though is we had class earlier. So those of you who missed class didn't get to see the trials that we did, but we did it 2 times. In our first time, we got 6 favorable outcomes. The second time we did it, we got 7 favorable outcomes. And then when we did it just now, we got 3 favorable outcomes. Remembering again, the favorable outcome for us is heads. So each time we did it, we had 30 trials. So right now what we're going to do is we're going to combine those 30 trials and the favorable outcomes of them and see what we get. Because at this point, if we combine it, then that means we have a larger sample to evaluate. So let's put 30 down here. And then 6 plus 7 is 13. Plus 3 is 16. Ooh, look, guys. Look how close that is. That's pretty much almost 50%, right? So did this experimental probability match up a bit closer to what we got when we did the theoretical probability? It does, because an exact 50-50 number would be 15 over 30, because that equals 1/2. And we got 16. So it definitely was a lot closer. So with that being said, I mean, there will be times when you're flipping a coin, and I mean, it might be very, very rare, very, very rare. However, I mean, you could very well flip a coin and it could land on heads all 10 times. The likelihood of that happening, not so much so. However, can it happen? Of course it can. So let's go ahead and go to the next slide, where we're going to go ahead and try some examples. So what we're going to do now is talk about the die. So we know that the die has 6 sides, right? So if the die has 6 sides, then that means that there are 6 possible outcomes if we roll the dice, right? And our possible outcomes would be, hold on, let me get my pen back up. Our possible outcomes would be 1, 2, 3, 4, that is the comma, 5, and 6. I'm sorry, the marker is very large, so my handwriting, you already know it's not going to be the greatest on here. Okay, so those are our possible outcomes. So that's 6. In the first example, remember that when we have a P in the parentheses with something inside of the parentheses, that means the probability of, and then whatever's in the parentheses is the event. So just to refresh your memory, because we learned this last time as well, P is the probability, and whatever is in the parentheses is the event. Okay, so in this situation, so in the situation that we are dealing with right now, they want to know what is the probability that we would roll the number 2 if we were rolling a die. Now, what we need to figure out is how many 2s are on the die. So when we wrote our numbers out up here, how many 2s do you see? We only see 1. And if we look and think about our formula, the favorable outcome is 2, and that goes on top. The number 2, but it's only one of them, but that goes on top. So we have 1, 2, and then the total number of outcomes is 6. So then that would be our probability of the die landing on the number 2. So now let's look at example 2. We want to know the probability of a die being less than 5. So less than 5 is not including 5, it's just the numbers below it. So we're referring to 1, 2, 3, and 4. So that's 4 numbers, right? So if the die rolls on any one of those 4 numbers, that would be favorable for us because that's what we're looking for. However, if it lands on a 5 and a 6, not so much so. So the favorable outcomes is going to be 4, and that's going to go on top, right? And then on the bottom is the total, which we know again is 6. However, we always know that we have to make sure that this is in simplest form. So we know that we can simplify 4 or 6. So if we divide 4 by 2, we're going to get 2. And if we divide 6 by 2, we're going to get 3. So then our answer is going to end up being 2/3 because we have to simplify it. Okay. So in example 3 is asking, what is the probability that we are going to roll a 1 or a 2? So now in this situation, they're saying that, it's going to be favorable for us either way. So we're looking at both numbers. We're looking at 1 and 2. And if we're looking at our sample space, we have 1, 1, and we have 1, 2, which is going to give us 2. So we have 2 favorable outcomes, and we have 6 total outcomes. So that's going to be 2, 6. Can we simplify it? We can. If you divide 2 by 2, you're going to get 1. And if you divide 6 by 2, again, you're going to get 3. So then 1/3 is going to be our probability. And then the last one, they want to know, what is the probability that we're going to roll a number that is less than 10? Well, is this a trick question? Because there's only 6 sides, right? So that's 6 numbers. So every outcome is going to be favorable because everything is less than 10. So that's going to be 6 because that's 6 favorable outcomes, and it's 6 total outcomes. So the probability of that is 100%. Okay? All right. So these are going to be ones that you're going to get to try on your own. So what I want you to do is I want you to go ahead and try them on a piece of paper. And what you're going to do is you're going to take a picture. Once we get through the whole lesson, what you're going to do is you're going to take a picture of what you got for each one. So you'll have to actually write P, the parentheses, and then whatever the event is. So if you're doing the first one, what I want your sheets to look like is P and then even, and then you'll have an equal sign, and then you'll put whatever your answer is. I'm gonna go ahead and do this one with you guys. So this is what I want you to write. P even equals, and we're gonna look at our size, and it's 1, 2, 3 even numbers. So those are going to be our favorable outcomes. We'll put 3 on the top. We know it's 6 total. And we also know that this can be broken down to 1/2. So then that would be the probability, and that would be your answer. So that's how I want you to write it. Okay, guys? So anytime you see you try, those are the ones that you are going to do, and you're going to upload the picture so that I can see. All right, so let's go down to another sample. So now we're doing experimental probability. And again, what is experimental probability? It is what we actually get. It's the actual results. So since we're not in person, we've already rolled the die. So we've already got the results. So we're just going to use what we have, okay? All right. So a 6-sided die was rolled 10 times, and the results are displayed below. So we're going to find the experimental probability. So for the first example, they want to know the probability of 2. So what we're going to do is look at our chart, and we're going to see how many times we rolled a 2. So let's see the results. Oh, there's 1, 2. So it looks like we only rolled a 2 one time. So our favorable is going to be 1. That's the actual outcome. The amount of trials was 10. So then that is the probability, 1/10. Now, if we are talking about the example, and then we're talking about the example for the theoretical probability, those numbers were different. But again, why were they different? Think about it. Why were they different? They were different because the theoretical is what the probability should be, and the experimental is what it actually was. So again, if we did this experiment and we allowed it to go on for 1,000 trials, then 9 times out of 10, it's going to be closer to what we got or whatever we had for our theoretical probability. So let's do, they want to do even numbers as well. So we know that we have, let me see, we know that we rolled 10 times. So let's go ahead and clear the screen and let's go ahead and count and see how many even numbers we have. So 1, 2, 3, 4, 5, 6. We have 6 even numbers. So we're going to put a 6 here out of 10. And that can be simplified. So let's go ahead and divide it by 2. And if we divide that by 2, we will end up getting 3/5. And that would be our answer. Okay? So this whole side is what you guys are going to try on your own. Everything that says you try is what you're going to try. Okay? All right. Okay. So I actually wanted to talk about experimental probability, but from the aspect of a deck of cards. And the reason I wanted to go ahead and go over it now is because we actually are going to utilize a deck of cards sometimes in order for us to figure out some of the probability questions that we have. But in order for you to answer the questions, you have to be pretty familiar with a deck of cards, okay? So just in general, just take notes because you will use this in the future. Plus, it's something nice to know, I guess. So in a deck of cards, there's 52. Okay, we can't write with that. There's 52 total, 52 cards. Out of those 52 cards, you have 13 sets of each spade, hearts, diamonds, and then you have clubs. So each of those get 13. Depending on the kind of the type of cards that you have, there will be there may be 1 or 2 jokers that come with it. Typically, we're not gonna really deal with jokers. When we think about the 52 cards, we're really thinking about the 13 spades, hearts, diamonds, clubs. So let me see what else. Not an ace. Okay. So when we are thinking about the 13 cards, number 1, it starts with the number 2. So let me change the color. So it starts with the 2, and it goes all the way up numerically until it gets to the number 10. After 10, then that's when you have your face cards. You have a jack, you have a queen, you have a king, and then you have an ace. Okay? So I'm sure you guys are somewhat familiar with cards, but just in case, I just wanted to break it down for you before we actually got into the experiment below. So I'm just going to read the problem. So a card is selected 10 times from a standard deck of 52 cards. Each time a card is selected, the result is recorded and the card is placed back into the deck. So what we're going to do is we're going to find the experimental probability. All right. That is very small. So let's see if we can make it a little bigger. I'm not sure if we can or not, but we're going to try. Let's see. Yeah, it's definitely not allowing us to make it any bigger. So it's okay. I will just tell us out loud what we have here. So the probability of 5, we're going to look and see how many times, or if any, that we picked a 5. So I see we have one here, and we have another one here. So we have 2. So out of 10, we picked it twice. So we're going to have 2 over 10. We can simplify that if we divide them both by 2, and then it'll give us 1/5. Okay. So what about the number 7? So I'm going to go ahead and clear the screen, guys. So what about the number 7? Well, I see a 7 right here, and I see a 7 right here. Do we have any other 7s? Oh, no. So we're going to write the same thing. 2 out of 10, which we just also said is also 1/5. A number card. Okay. So now let's go back up after we clear the screen and see how many number cards we got. 1, 2, 3, 4, 5, 6, 7. Where you see the J, that stands for Jack. Where you see the A, that stands for Ace. And when you see the K, that stands for King. So how many do we have total? 1, 2, 3, 4, 5, 6, 7. We had 7 number cards. So we're going to have 7 over 10. Can that be simplified any less? Nope, it can't. All right, so what about odd numbers? Let's see how many odd numbers we have. We have 1, 3, that's an odd. We have a 7, that's odd. 5 is odd. 7's odd. And 5 is odd. So 1, 2, 3, 4, 5. So we have 5 out of 10, which is also going to be 1/2. Next, we have what is the probability that it's not going to be an ace card? So it looks like 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 cards that we played were not an ace card. So that's 9 out of 10, and it can't be simplified any further. And then the last one is what is the probability of pulling a 5 or a 7? So again, 1, 7, 1, 5, 1, 7, 1, 5. So how many do we have total? 1, 2, 3, 4. So it would be 4 over 10, and that can be simplified. So what if we divided it by 2? That would give us 2 over 5. And that is a probability for us. So I want you to go ahead and try the ones. This is going to be posted on Google Classroom, and you'll have the section that says "You try." That'll be a picture under Google Classroom, so you can just upload your picture under that post. Okay. Um, One more thing that you guys have is you have homework to do, and it's going to be on both theoretical probability and experimental probability. It's literally basically what we just did, except you're doing it solely on your own. So this worksheet will also be on Google Classroom as well, but they're separate things. You know, the you try is just going through what we did in class, but this is your actual homework. So I will also post this onto Google Classroom. So if there are any questions that you have, I think tomorrow you guys you're in cohort, I believe, most of the day. So tomorrow's a good time to shoot me an email, shoot Miss Walton an email. If you have any questions, I'm available to Zoom with you guys anytime throughout the day. So if you shoot me an email, whether it's today or tomorrow, just let me know and we can go ahead and go over some of the problems and we can do a live Zoom call. So I hope you guys have a good evening.